Well, my definition of acceleration involved 3D vectors, so let's do an example. I hope you think it would be easier, to, at least for a first example, to look at a 2D version.
I agree.
Well, I'm glad you agree. So we're going to let r of t be 2 cosine of ti plus 3 sine of tj. But we're going to sketch the path, the velocity, and acceleration vectors at the point where x is 2 and y is 0. And so if x is 2 and y is 0, you can probably see that that means cosine of t would be equal to 1 and sine of t would be equal to 0. So therefore, the point 2, 0 is like 2 units of I and 0 units of j would be at the point where t is 0. So, first finding the velocity vector, the derivative of 2 cosine t is negative 2 sine t, so negative 2 sine ti. The derivative of 3 sine tj is 3 cosine of tj, and so there is our velocity vector. And at the point 2, 0, t equals 0. I think I've already explained why that's so. So the velocity vector would be negative 2 times sine of 0 is 0, so just 0i. And then, since t is 0, plus 3 times 0j, so is 3j. And the speed would be the length of the vector 3j. I don't even have to do square root for this one if I don't want, because I can just see that the length of vector 3j is 3 units. Even if that was negative 3j, the length, that is the speed, would still be 3 units. And the acceleration vector is the derivative of this velocity vector, so the derivative of negative 2 sine t is negative 2 cosine t, so negative 2 cosine ti. The derivative of 3 cosine t is negative 3 sine t, so negative 3 sine tj. So there is our acceleration vector, which is the second derivative of the position. And at the point 2, 0, where t is already known to be 0, we have the acceleration vector is negative 2i, because see, if t is 0, then cosine of 0 is 1, so we get negative 2 times 1i. And sine of 0 is 0, so we got 3 times 0 times j, so it's just negative 2i for our acceleration vector. And here's a picture of the vector valued function. This is how I use my software to just draw it as if it was parametric equations. X equals 2 cosine t, y equals 3 sine t. That's, recall, the original vector value function itself. So here that is, although what I don't have is a direction of motion on here. I can't do that with my software, but if we started when t equals 0, then we would have 2i plus 0j, so we'd be starting at this point right here and moving counterclockwise. So, and then the directions say to find at the point t0 the velocity vector, which is 3 times j, and the acceleration, which is negative 2 times I. So here they are drawn in here. I have the velocity vector drawn in blue, is 3i, pointing north at this instant, and the acceleration is pointing west at this instant, going in towards the origin. And since it's negative 2i, it has length 2. The velocity vector has length 3, so at this time it's going at a speed of 3, whatever our units are.
I know! I agree.
Well, I'm glad. Okay.